Hello everyone, I'm going to solve the next problems is the solution of part 2. So the problem number 6 says that f is defined to be a function from R to non-negative reals such that for any finite set summation fx on x belongs to e less than 1. We have to consider the set where f takes non-zero value, and what can you say about that set? Okay, so since there is no restriction given on f except this summation condition, you can define in this way, like define a function f. So define a function f from R to 0 infinity such that fn is 1 by 2 n square when n is natural number, 0 otherwise. Then you can see that summation 1 by 2 n square is pi square by 12, that is less than 1. Hence summation fx x belongs to e is less than n for all e side r. So this function satisfies the given condition, and you can see that the cf is basically here. Cf is natural number, so it is not a finite set, not even a bounded set, it's a countable set. And also you can do the similar argument by sequential argument, and say you are defining the function for the sequence 1 plus 1 by n whose limit point is 1, some non-negative values, and for minus 1 plus 1 by n some non-negative values and otherwise 0. And so that you are defining in such a way. Similarly, this sequence type of argument you can do in this way so that it becomes sum on any finite set becomes less than 1. You can do it easily. Then you can see the option C will be also wrong. So clearly option D will be correct. Okay, it's a pretty obvious question. So the next one, let P be a prime. Which of the following statements is true? That there exists a non-commutative ring of being with exactly p elements, there exists a non-commutative ring with exactly p square element, there exists a non-commutative ring with exactly p cube elements. Okay, so I'm going to construct a general setup. Okay, so let p be any prime. Okay, consider set of all 2 by 2 upper triangular matrices over Zp. So I'm considering this set. Okay, so clearly this forms a ring, right? Under the usual ring, usual addition and multiplication. Clearly it forms a ring under usual addition and multiplication, and also it is non-commutative because you can always pick to get to matrix as that product will not be the same. I mean, product of AB and product of BA will not be same, and cardinality of AP is basically P cube because choice of A is P, choice of B P, and choice of C also P because it all belongs to ZP, so it is P cube. So this is a non-commutative ring of elements, number of elements P cube. And you should think why other two options are wrong. Okay, I'm not going to elaborate, but also the other two options are wrong, like for option A and B. So option C will be the correct. Okay, so now question number 8 is not straightforward. I will solve it in a different video. So I'm going to solve some easy problems now. So question number 9, it is easy one, so you can solve it in this so this one, right? So you can directly solve it. I'm going to solve. It's a straightforward problem. Like, so it is given that y dash is basically equal to sine square y, then So basically dy dt given as sine square y. So dy by sine square y is dt. You can integrate both sides. You will get minus cot y, basically t plus c, where c is the integrating constant. Now it is given the initial condition that at t equal to 0, y is 1. So c is basically minus cot 1. So you have y equal to cot inverse cot 1 minus t, and cot inverse is bounded but not periodic. If you know the graph of cot inverse, then you can see not periodic. Okay, so or you can check by giving some value. So it is not bounded but not periodic. It's bounded but not periodic. So option C will be correct. Also, I'm not going to solve problem number 10 because it is just computational problem. It asks that which of the following subgroups is normalizer of itself. So you can easily see that B, C, D are normal subgroup. Okay, if you check, you can see that's a normal subgroup. So only option A will be left, and so option A will be the correct answer. Not a difficult one. So now come to the problem number 11. Problem number 11 is also a previous year question paper of TIFR. I think that problem comes in true false section, so that's why it may be difficult. But this one is, if you don't know anything, then also you can solve it by discarding other options. Okay, so let's see. So consider x to be 10 cycle in S11. Then clearly x to the 10 is identity, and identity cannot be conjugate to any non-identity element, right? Identity cannot be conjugate to any non-identity element, so n cannot be 10 here. Again, similarly, you can take x to be 11 cycle. Next to the 11 is also identity. By similar argument, n cannot be 11. Again, you can take x to be a 3 cycle, then x cube is identity, then x to the 12 is identity, hence it cannot be 12. So 13 will be the correct answer. So by just discarding method, you can solve it. But I will tell you to think about it. Why for every element x to the 13 and x is conjugate? So to do that, you can use a result, a very important and interesting result, that in Sn, any two elements are conjugate if and only if they have same cycle representation. Okay, so in Sn, any two elements are conjugate if and only if they have same cycle representation. That means a 4 cycle cannot be conjugate to a 3 cycle. Again, a 5 cycle always conjugate to a 5 cycle. I mean, any two 5 cycles are conjugate. So it's a if and only if condition. So by using this result, you can show that x to the 13 and x are always conjugate. Okay, I will ask to think about it. If you don't know, you can comment. I will reply. Okay, it's not, but it is. You can use this result and you can use some GCD argument of 13 and 11. You need to use that. By using that, you can show that in S11 this happens. Okay, so here S11 is very important. So here in S11, x to the 13 and x are always conjugate. Okay, in particular, if you choose in S13, x to the 13 and x are need not to be conjugate, because you can take a 13 cycle and then you can say the similar argument. So here 11 also plays a crucial role. So x to the 13 and x are conjugate. To show that, you need to use that here S11 here. I mean, you are seeing the elements in S11. Okay, so that also plays a crucial role. Okay,